Hello and welcome to another exciting chemistry session. This is your host, Mr. Monsa. We're still in the series of energetics of reactions, and today we're going to look at the third and just within the third objective, uh, describing endothermic and exothermic reactions in relation to bonds. So uh, in the previous session, we looked at how to describe endothermic and exothermic reactions in terms of energy, heat loss, and heat gain. And then we looked at a few examples of exothermic and endothermic reactions. And from there, we demonstrated a practical on how we can determine which reaction is endothermic and which reaction is exothermic. Now, thinking about endothermic reaction in terms of bonds, we say, allow me to use, okay, let me use a whiteboard. Yeah, so thinking about endothermic and exothermic, so endothermic, exothermic in terms of bonds. So endothermic exothermic. So in terms of bonds, endothermic is called bond breaking. Then exothermic is called bond formation. So basically what happens is when we have a chemical reaction, for example, we have A reacting with B, then producing C plus D. So for us to have the reactants resulting into the formation of products, we said energy is involved. So energy is supposed to be absorbed and then released. So when we talk about absorption of energy, that is what we call endothermic. So in this just general reaction, we say on the reactant side, that is where we experience what is known as the endothermic reaction. And then on the product side, that is where we experience what is known as the exothermic reaction. What do we mean by this? So when you look at the reactants, or the reactant particles, so these reactant particles, they consist of bonds. I can give an example of H2 plus O2, then resulting into the formation of H2O, So hydrogen combines with oxygen to produce water. When we look at hydrogen molecule, this is hydrogen consisting of a single bond between the hydrogen and hydrogen, and then we have oxygen consisting of double bonds between the oxygen atoms, and then we have oxygen bonded to hydrogen and oxygen bonded to hydrogen. So basically what happens is, so this is your product, and these are your reactants. So what we are saying by endothermic reaction being bond breaking and exothermic being bond formation, the meaning is that on the reactant side, we are saying we have an endothermic reaction, meaning bonds will break, bonds, bonds, bonds break, bonds break. Then we have bond formation on the other side, bond formation, bond formation, bond formation. So on the reactant side, the bonds are supposed to be broken. So they absorb the heat energy. We said endothermic involves absorption of heat energy. So that energy which is absorbed goes into the system, and then it is responsible for the breaking of the bonds. So the hydrogen-hydrogen bond will be broken. So that bond will be broken. The oxygen-oxygen bond will be broken. And then there will be a rearrangement. There will be a rearrangement which results into the formation of products. So there is an intermediate and then the products. So at the intermediate, that is where you find the bonds broken. So we're going to have hydrogen, hydrogen, and then we have oxygen, oxygen. So this is at intermediate before they join into the formation of uh, it results into the formation of the product. So there will, they will reach a point where the bonds are broken and then rearranged. So they are rearranged, and then we're going to have the hydrogen oxygen bond and another hydrogen oxygen bond, which results into the formation of water. So endothermic involves bond breaking, and exothermic involves bond formation. So during bond formation, energy is released, and during bond breaking, energy is absorbed. So basically, that is how we describe endothermic and exothermic reaction in terms of bond formation and bond breaking. So I hope that is very, very clear. So from there, we can now look at what we call the energy level diagram. We can look at what we call the energy level diagram. Energy level diagram. Okay. So basically, that is the description of endothermic and exothermic in relation to the bond. So endothermic bond breaking. The reactant particles break their bonds, and then on the other side, which is the formation of the products, energy is supposed to be released, and then the atoms on the reactant side rearrange, and then they result into the formation of the product, which is an exothermic reaction. Now, I would like us to talk about the energy level diagrams. So we have visual representation of an exothermic and an endothermic reaction, and that visual representation on the x or y plane is what is known as the energy level diagram. So the energy level diagram are just graphical representation of energy changes. So it shows how the energy is changing in a reaction, whether the energy is being released or the energy is being absorbed. So energy level diagrams, they have a vertical axis which represents the overall energy, and then we have the y-axis which represents a reaction progress. So what we're looking at here is an example of an exothermic energy level diagram. An exothermic energy level diagram. So on the y-axis, we have the energy, and on the x-axis we have the reaction path, which shows how the reaction is progressing. Now, just to add more details, or just to explain further the meaning of this diagram. So we have y-axis. Straight. We have okay. We have the y-axis, which is represented by energy. Represented by energy, and then energy is in kJ. Kilojoules, and then we have the reaction progress. The reaction progress. So we're looking at the energy level diagram of an exothermic reaction. So we're going to have energy of reactants and energy of products. So basically what happens is a reaction can start, for instance, say this is 50 kilojoules, and that is 200 kilojoules. So let's say a reaction starts from there, it goes up, and then it comes down. So we have the reactants there, and we have the products. So we are interested in knowing the change. We are interested in the change between the reactants and the product, and that change is known as the enthalpy change, which is denoted by delta H. So the energy difference between the reactants and the products is known as the delta H, which is known as the enthalpy change. So the enthalpy change, we're going to notice that for the products we have 50 kJ, and then the reactants we have 200 kJ. So to calculate the enthalpy change, we say the enthalpy change of this reaction is equal to the energy of the product minus the overall energy of the reactants. So that is a formula that we use. Therefore, we'll say 50 minus 200, and this will give us a negative 150 kJ. So our interest here is the negative sign. Our interest is the negative sign. So what this simply means is that for an exothermic reaction, your enthalpy change is always a negative value, is always a negative value. So whenever you get an enthalpy change which is negative, it basically means that that reaction is an exothermic reaction. Basically means that that reaction is an exothermic reaction. So that is the meaning of what we have right here. So basically that is the meaning of what we have right here. So it's the energy of the reactants sitting above the energy of the product. So when you calculate, you get a negative enthalpy change. So the enthalpy change is given by the energy of the products minus the energy of the reactants. So that is an example of an exothermic reaction. We can look at an endothermic and endothermic. So for an endothermic, it's just the opposite. So for an endothermic, okay, so that is our y-axis and then our x-axis. So reaction progress and then the energy. So the energy, as usual, is in kilojoules. Energy is in kilojoules. So we have energy for the reactants, overall energy for the reactants, and overall energy for the product. So this reaction will start from here, goes up, and then the product somewhere there. So these are the products, and that's our reactant. So we are interested in the difference, the energy difference, which is here between the products and the reactants. So that is known as delta H. So let's say this is 50. Let's say this is 50 kilojoules. So the reactants are sitting on 50, and then the products are sitting on 200. So let's calculate the enthalpy change. So the enthalpy change will be given by the overall energy of the products minus the energy of the reactants. So we have for the products, we have 200, and then for the reactants we have 50. So substituting these numbers in the formula, we have 200 minus 50. When we subtract, we'll have a 150. 150. But what is important about this 150 is that it comes with a positive sign. So we say the enthalpy is a positive value. Remember, this is an endothermic. This is an endothermic reaction. So for an endothermic reaction, our enthalpy change or our enthalpy value is always a positive. So exothermic, the enthalpy is negative, endothermic, the enthalpy value is positive. So we can also distinguish endothermic and exothermic in that particular aspect, looking at their enthalpy change. So we can talk about them in terms of energy. So in terms of energy, endothermic, we absorb the energy. Exothermic, we release the energy. In terms of bonds, we We say endothermic involves bond breaking and exothermic involves bond formation. In terms of enthalpy change, we can say exothermic, we have a negative enthalpy change, and endothermic, we have a positive enthalpy change. So those are just examples explaining how we can determine the enthalpy change of an endothermic reaction. But basically what is important is knowing that a positive value means endothermic and a negative value means exothermic. So in terms of energy level diagrams, that is how we interpret the energy level diagram. So we can calculate the enthalpy change and then we can make a comment on that particular enthalpy change that we have calculated, looking at its symbol. Is it a positive value or is it a negative value? So basically that's what we had for today's session. Until we meet next time, bye bye.